So I'll be discussing assignment number 11. It's very simple. Sir has already explained all of this in his classroom. So the first question asks that which of the following sentence is true regarding bonding between adjacent layers of a composite laminate. So the first statement states that thickness of the laminate is equal to the sum of thickness of individual layers. This is definitely true, which is always correct for micromechanics approach. And the second states that bonding between two layers is perfectly rigid. That is, we assume that they are highly bonded and the interlaminar bonding is very very high. So therefore both A and B both are correct. In second question they have asked that each stress component in a laminate uh, is what? So stress follows the Hooke's law in the initial elastic zone. So stress within the layer is linear, while that between adjacent layers depends on the mid strain of that particular layer and the distance between the mid plane and the adjacent planes, and therefore it's discontinuous across the adjacent layers. Then matrices A, B, and D are the extensional coupling and bending stiffness matrices. That is universally true. Then all symmetric matrices are cross-plane laminates, and therefore fourth answer is C because it's symmetric with a central plane as 90 degree. Then in the fifth question, there was that which of the following laminate has a zero matrix? So symmetric matrix are the ones which have zero matrices. As C is the only symmetric matrix, therefore C is the correct answer. In sixth question, it has been asked that which one of the following assumptions does not relate to classical lamination theory. So classical lamination theory is the theory which is used for predicting micromechanics of the composite. As per this, each lamina is orthotropic and is in state of plane stress. This is the basic assumption which we um consider while classical lamination theory. Then the thickness of the laminate is the sum of all the individual layers. This is also true. And the lamina behaves elastic. This is true. Then the fourth assumption is that the interlaminar bonding is perfect, while in here it is given that slip may occur between lamina interfaces. So therefore D option is wrong, as per classical lamination theory no slippage is possible and the layers are highly interbonded. In seventh question, it's asked that for non-symmetric laminates, which of the following is observed when they are subjected to thermal loads? So, wattage is a condition which is commonly used for defining thermal loads. As failure may also occur, but failure occurs only mainly under tensile compressive loads and when interface between fibers and matrices break. Warpage is the condition which is seen when thermal loads are given. Um, the next has been asked that the extension stiffness matrix A for the laminate will not change if. So the answer is it will not change when stiffness, the stacking sequences change because extension stiffness matrix depends on the material properties of the composite and not on the stiff stacking sequence. Then mid-plane curvature of the laminate are zero according to classical laminate theory if. So it is only possible when the laminate is symmetric and it's subjected only to in-plane forces. This is an assumption which uh, we consider while obtaining laminates with zero matrix values, and therefore C is the right answer. Then which of the following laminate will not undergo